Good morning. This is Tim Stewart. I am president at Visual Decisions, and we're here today to talk about using the industrial Internet of Things and business intelligence together to drive performance improvements. At Visual Decisions, we've been in the business of utilizing information from the shop floor to improve continuous improvement since about 2002. We help our customers combine the smart factory with the lean factory to drive improvements to cost, throughput, and quality. Our customers have seen dramatic improvements, such as 30% increases in OEE, 50% scrap reductions, and much more. But just like wearing a Fitbit won't automatically make you thin, implementing technology for Industry 4.0 won't automatically make the business better. The culture of the organization and the business processes must be adapted to take advantage of the new capabilities to drive real improvements. That is why we have a unique approach to work with our customers to adapt processes to take advantage of the new capabilities and help establish a true data-driven manufacturing culture. So, as a quick procedural note, if you have questions during the presentation, please enter them into the Q&A and I will get to them at the end of the webinar. Thank you. So, to start off with, we'll just do a very quick section on what is IIoT, or the Industrial Internet of Things, and what is business intelligence, or BI, and kind of when do we use each. So IIoT describes the network of physical objects or things that are embedded with sensors, software, and other technologies for the purpose of connecting and exchanging data with other devices and systems over the internet. The definition of the Internet of Things has evolved due to the convergence of multiple technologies, real-time analytics, machine learning, commodity sensors, and embedded systems. A lot of traditional fields and others will continue to enable the Internet of Things. And a lot of systems that we have in place today have kind of grown, are the precursors of these systems and kind of have grown some of these capabilities themselves. For our purposes today, we'll be discussing the IIoT software platforms, such as the ThingWorx system sold by PTC is kind of the biggest one out there right now. These platforms consist of several primary components: data collection, data routing or persistence, event processing, communication for alerts and so forth, development environments, mashup or user experience builders, machine learning or AI systems, various widget libraries, and very, very extensible APIs. They typically ship with kind of little out of the box functionality. And the idea is that they provide the complete toolkit to build any application within the sphere of, IIoT. It's a fuzzy term that encompasses just about anything if you ask the right person. So then what is business intelligence? These are the modern platforms that are out there, are things like PowerBI, Tableau, Qlik, and some others, but those are kind of the heavyweights that are out there. And they are composed of a number of different capabilities, such as analysis, data discovery, data science can fall within this overall effort and so forth. There's a heavy focus on data visualization and dashboarding, reporting within here. And so you really pull together a lot of these different disciplines, but the idea is that you are attempting to democratize the data analysis within your organization. And you're trying to provide those capabilities to have both a guided workflow to analyze the data, as well as providing ad hoc capabilities for users to develop their own analysis. So what are the primary strengths of each system? For business intelligence, it's really built to blend data from multiple different data sources together. And it's also meant as a point of consumption for that data. It's built as a hub for analysis. It doesn't look to own the data. It's looking to pull data from other places and display it within that system. It's nearly infinitely flexible and extensible to provide pretty much any analysis framework that you would like within that environment. Um, it can easily you can easily build the guided analysis, but it can also support the ad hoc analysis, and it easily coexists with other systems. So really, it's meant as a front end, and the focus here is primarily on historical data. It's not as much of a real-time system because this doesn't own that data. It's not the system where that data is being generated. And so there's going to be a lag between whatever the data source is and when it gets displayed within the BI tool. On the other hand, the industrial Internet of Things systems are built for connectivity. They are at the point of generation for the data. And they're built as a hub for the shop floor. They don't look to own the data again, but they can be the center of best-in-class solutions. So if you already have systems such as a quality system and maintenance system on MES and things like that, the IIoT systems can very easily sit between all of those, act as a hub to pass information back and forth on the shop floor, but then also provide those additional capabilities by putting some unique sensors in place and unique structures for doing that analysis, doing that alerting, and so forth. Once again, they're nearly infinitely flexible. They are essentially a development toolbox with some built-in capabilities, but they can exist at the edge or in the cloud. And once again, they easily coexist with other systems. And so if you want to have it, kind of broken down very simply, the IoT system is going to exist, to collect that information from the shop floor, piece together the context from different systems, and then persist that information out to, a database. And then the IoT system can also be used for real-time visual controls and other, real-time or near time interfaces out on the shop floor, and alerts and communication. The BI tool is going to take that information once it has been persisted, and now it can utilize that information to do kind of that overall historical analysis, and also provide additional dashboarding with maybe context that you don't want to pull into the shop floor system, such as from your ERP system or other external systems such as those. So with that, let me get into some of the use cases that we at Visual Decisions really look at. And so we have a focus on kind of transforming operational excellence or operations to utilize all of these Industry 4.0 technologies, of which these two solutions embody several different capabilities. And so when we look at this new world of work, there's a heavy focus on the technology itself, but as I talked about with the Fitbit at the beginning, you really have to focus on the people and the process within here as well. The example with the Fitbit, I've been wearing one since about 2013, and I have definitely not lost any weight during that time. And so when I look at why I haven't lost the weight, even though I have the Fitbit works. It tracks all my steps. It has wonderful sensors. It puts that information up into the cloud. It has some wonderful cloud-based analytics that provide me all kinds of pretty charts and graphs and so forth to give me all the information I need to lose the weight. But I haven't lost the weight because I haven't changed my behaviors. And really, it's changing those behaviors, changing the way that I approach things that will help me lose the weight. And it's the same thing on the shop floor, only writ larger. You're not going to lose the waste in the organization unless your people actually change the way that they do work, change their behaviors, change the process, and utilize that technology to its fullest. So if we look at manufacturing, it has done a great job of embracing a lot of these technologies over the past 20 years. laser cutting, robots, cobots, augmented reality, all kinds of different technologies. You can't walk through a modern factory without seeing these things. But then you'll see these whiteboards and lots of paper that's being used for tick sheets and other things within continuous improvement. And we really feel there's an enormous opportunity to use these IoT systems and BI systems to really augment what's being done within those different areas. So if we look at how to transform operational excellence, it's possible to create a lean management operating system using these modern solutions that maintains all the benefits of the old ways of doing things, but then gives you so many more new capabilities. And then, just if we take that lean toolkit that we've had for years and years now, decades really, that hasn't really been adapted that much, you can do root cause analysis so much more easily than you used to be able to. Value stream mapping and FMEA should be automatic these days instead of something that still takes a huge amount of effort, and so much more. So if we look at something as basic as standard work, how can Industry 4.0 solutions help standard work? Well, first of all, you can deliver the right information to the right place at the right time, and getting that information to the people so that they can actually see the standard work in their environment, knowing what to do for the unit that's in front of them at that time is huge just in itself. You don't have to go and look up things in a book. You don't have to go to a separate area and look something up. You get the information delivered to you right as you're doing your job. And if you add in augmented reality solutions, there's even more capabilities for delivering that right information to the right place at the right time. Augmenting the people in the organization with new capabilities, taking some of the machine learning capabilities for classification and understanding some of the data streaming that's going on so that you can give people information instead of just the raw data is tremendously powerful. You can utilize these systems to kind of standardize these new work practices as well. So they're an opportunity to, kind of harden the work process that you want to see in people by putting those things into the technology itself. And then you can also detect and elevate attention to deviations from those standards. So if you see people that are, setting the dial to someplace that they're not supposed to while they operate the machine, that can be instantly noted, and you can alert somebody that can, go and use that as a training opportunity. This is an example I use all the time of, a visual control of, a safety, quality, delivery, cost, and manpower. Having a board out there that, you either print off Excel sheets and stick them in the little plastic pieces, or you're coloring things in by hand, or you have a whiteboard that you're going up there and writing numbers on manually and so forth is, one way to do it. It's very wasteful because you have people that have to walk out there. If you want to then capture this information on a more permanent basis, you have to have somebody actually now take that, type it into probably Excel. And then you have a whole bunch of different Excel spreadsheets. And if you want to do analysis over time, now you've got to pull all those Excel spreadsheets up and combine information again. Even if you're putting it into like an Access database, you still have to then tie that Access database into something else in order to contextualize that data. And so there are so many better ways to do this. And we can capture the information directly from the machines, have a real-time big screen display out there that shows all of this information and shows it in a way that you can actually now drill into that data and get more out of it. And I'll touch on, I don't want to get too much in this presentation onto, the manual versus, automatic ways of doing this, but I will touch on this real quickly. There's a great book, Creating a Lean Culture by David Mann, that goes into details from the early 2000s perspective of why the manual controls were so much better than what IT could provide. And at the time, they were. It's just not the case here in 2021. With these Industry 4.0 solutions, you have so many capabilities to make this information more timely, more accessible, more precise, more verifiably accurate, prompt a lot of questions for conversation. They can be extremely easy to change and customize. There is no intimidation factor with these screens anymore. Everybody looks at smartphones and tablets all the time. And so you don't have that kind of intimidation. What's actually more intimidating is for people to have to do math themselves to, put the things up there on the whiteboard and so forth. The ownership is, something that you build through the standard work and the use of this information, as opposed to writing the numbers down in the first place. This information can be available instantaneously across the entire world if you want it to be so. And then, the accuracy and, is so much better than, doing things manually. It does require more overhead. So that's still an advantage for a whiteboard. But everything else that we just listed is an advantage for doing this through an Industry 4.0 solution, as opposed to doing it through manual methods. If we look at things like creating a digital management operating system around safety, quality, delivery cost, inventory, manpower, environmental, these are things that, I've worked with a number of different chief operating officers, VP of operations, and they all have cadence calls, usually on a weekly basis, where they talk to their different plant managers, and they go through, a sequence of conversations around different KPIs. Key performance indicators. And in the particular example here, this company had gone through a Hoshin-Kanri or policy deployment process where they take the vision for the entire organization and they break that down by level into what are the objectives or measures that we should be having at each individual level of the organization, and how do we track that and so forth. And so they were using spreadsheets, of course, to do that, where the plant managers would have to have their people come in, look up what had happened during the week, type those numbers into that spreadsheet every week, and then submit that. And then the CFO would have his meeting where he walked through the spreadsheet and looked at any exception. So he would only focus on the exceptions where there was a miss, the actual did not meet the target. And then he would look for, what was the explanation for that, and what is the corrective action that's being put in place, and who's responsible, when will it be done, et cetera. And he would just walk through with each plant manager, focusing on the exceptions, and go from there. Well, what we were able to do is to automate this so that we could utilize the IoT system to grab that information directly from the source at the machines, at the different testing equipment and so forth, pull that information from the different source systems where you may have, safety information or other things being captured, and then pull that into a BI solution where we can now create this workflow so that at the COO level, he's able to see things across his different plants, and he's able to look at these different metrics and have that same workflow with his people. But at the plant level, they could drill into that, and they would have their view where you could have, kind of a subset of those different measures, or you would have, additional measures in some cases that are at that particular level. So you have the same general workflow, but it's, applicable to each and every level as you go down through the organization. And so you're able to create that top to bottom alignment. And we're able to do that with the combination of the IoT systems, pulling that information from the shop floor, and then displaying that workflow within the BI tool. If you look at a Kaizen process and you take there's a lot of different ways to organize them, but this is just a typical 6-step cycle of Kaizen, where you identify problems, you analyze the current process, you create solutions, you test the solutions, you measure and analyze, and then you standardize. when you look at this, every single one of those different layers is dependent upon data. If you're trying to identify, what are the biggest problems that I can go after right now, being able to have the data that tells you and points you in the right directions is huge. I started off my career in lean, walking around the plant with lean senseis, and they would point out 25 different things as we walked through the plant, and that is fantastic. It's a great ability, and I developed some of that over time myself, but what I actually very much prefer, as opposed to that, counting on, being able to see everything as it's happening right there, is that analysis that happens 24/7, that data collection that happens 24/7, and being able to see within the data a dollarized level of impact for the different issues that are both systemic and intermittent, and being able to see those things right there in front of me, and being able to understand which of the problems that need the most attention. Once I've identified those, being able to perform my root cause analysis, analyze the current process within the overall context of the operation and so forth. Again, absolutely, you have to have the data for that. And then, every other step along the cycle, you need that data. Well, the IoT system is going to help you collect that data from the different processes to begin with. And then the BI system is going to help you with that historical analysis and being able to contextualize that information with data, from those multiple different systems. And so both are extremely helpful, in this process. Again, with root cause analysis, whether you're using something as kind of elemental as who, what, when, where, why, how, asking why 5 times, using a fishbone diagram, going through some graphical evaluation, going deeper into an FMEA process, or utilizing some Six Sigma techniques, such as statistical analysis of factors with ANOVAs or design of experiments, et cetera. Having that data is the bedrock of being able to do all these different processes. And for things like this, if you're using the BI tool as your interface, you have the IoT system grabbing that information and pushing it to that historical data store. Being able to look at this information that's contextualized within that BI tool of who was operating the process, what happened, when did it happen, et cetera. Being able to drill into that data interactively to ask your 5 whys. Being able to fishbone that information to look at the different causes, something that you have to capture that information in that IoT system correctly in the first place. But certainly for graphical evaluation, a BI tool is fantastic. And then being able to do the FMEAs or the design of experiments and so forth, you can also support those more advanced processes with these same tools. So those are some kind of theoretical examples, and there's a million more, but we only have 45 minutes to talk today. So just some real world, some of the metrics that we can focus on to try to improve, with these types of processes, reducing the total cost of quality, improving throughput, reducing maintenance and tooling costs, replacing inventory with information, compressing the time to market, capturing new revenue streams, reducing risk, ensuring regulatory compliance. All of these are different operational improvements that we can target utilizing this combination of different tools. And I won't spend a lot of time going through the analysis of each one of these, but if you're interested, let me know and we can have a conversation around how you actually go about improving each one of these different factors utilizing these tool sets. So information on the total cost of quality here, improving throughput is usually coming down to reducing downtime, or improving or speeding up the production rates. Reducing maintenance or tooling costs, you'd have to reduce the amount of reactive maintenance that you're doing, improving your preventive maintenance, shifting to a predictive when possible. And then also, solving that tooling dilemma where if you leave the tool on too long, you create bad parts. If you take it off too soon, you have excess spend on your tooling. So you can utilize the real-time signals to optimize those tooling changes. Replacing inventory with information. Essentially, reducing inventory comes down to reducing the variability in the process. And I actually did that conversation in a webinar last week. So go to my website and take a look. Links to financial performance. If we do all of these different things, we impact just about everything on the income statement or P&L for our organization. And we impact quite a few things on the balance sheet as well. All right, so with that, I'm going to get into some examples. And I've got a whole lot of different examples that we've built over time. I'm going to go through a few in detail, and then I'll just fly through a whole bunch of them. So if we look at this example of work that we did for a bakery, we actually have this overview page that shows us lots of great information. And this was done using Qlik, and the majority of the examples that we'll see today were done using Qlik. We were grabbing information from the shop floor, utilizing Kepware, and then pushing that information to a database and so forth. And what we were able to do is to then pull information into Qlik to dollarize that information and actually look at what was the cost of that lost time, what was the cost of the material waste. And now we can look at that trending over time. And we can look at the day over day, the week over week, and the month over month numbers. And this is great information. And it's a great dashboard to look at to see how you're doing. But what it doesn't really do is it doesn't really tell you exactly, why you have those problems and help give you actionable information to address them. So the next thing that we did is every time that, we had a quality issue, we, captured what was the reason for that. Every time that we had downtime, we captured the reason for that downtime. And either grabbing that information from the PLC itself or having the operators give us additional context. And if we look at the charts up on top, we can see what were the biggest areas. Was it an equipment loss? Was it production loss, which was more of a process issue, quality loss, et cetera? And then what were the different categories, different causes? And one of the nice things about these BI tools is that they're extremely interactive. And if I click on this equipment loss, it will show, change everything else on the screen and show me, well, what are my biggest categories within equipment loss? And then if I click on the biggest category, it'll show me what is the biggest cause. And it helps me go through kind of that virtual fishbone of, going through that analysis. And when I do that, I see that in this particular case, the equipment loss was the biggest issue. The oven was the biggest area within, or biggest category within that area. And then if I look at the trending over time, I see that most days I didn't lose much time whatsoever, but then I had these big spikes. And what that tells me is that this is more of a preventive maintenance issue as opposed to, say, something I would attack through error proofing. And so what we were able to do is we captured additional information, and we found out that the oven shelves were flipping due to broken pins, and the pins were fatiguing, as they cycled through the oven too many times. And what we're able to do then is to just put a very simple PM activity in place that periodically, checked those pins for fatigue and replaced them where necessary. And by doing that, we were able to eliminate the single biggest cause of downtime in the entire factory and do that at a very low cost. But we could not have done that without the information that the system gave us. This example I went through earlier, it's that COO dashboard to put that operating system into place. A different example from a different company. Here's a plant manager dashboard where he wanted to see a lot of different information at one time so that he could at a glance see pretty much everything that was going on within his factory. whether that was scraps and defects information, production, the rolling trend of production at pack, different inspections, and what were the key different defects that were being spotted in inspection as opposed to the different processes down below. And then what is the combined first pass yield across the different areas within the facility. So lots of very detailed information, but great at a glance capabilities for that plant manager to see pretty much everything that he wanted to know. Some of the performance information, when we look at the amount of variability in performance, at different places, the production rate itself, even for a given line, a given product, can be quite high. And so the amount of data that the amount of product that we're getting out of that line at any given time was supposed to be a constant number. But whether it was due to micro stops or people adjusting the line rate, what we saw is that there was actually significant amounts of variation. So based on this, we were able to now start to drive into what were those actual sources of variation and perform that analysis to reduce that so that we could plan the facility much more effectively and get a much more reliable output from the process. Another example is this one is significantly older, but we've been doing this for a long time now. This was looking at maintenance information back in the mid 2000s, I think. So a very much older version of Qlik here, but you can see the basics were all there in terms of capturing what was that total downtime. What were the different reasons for that downtime, being able to visualize that in a couple of different ways, and looking at how that information is changing over time. This is an example of optimizing that tooling replacement that I talked about on the maintenance slide, where if you leave the tool on too long, you create bad parts. If you take it off too soon, you're spending too much. And so what we were able to do is our very first pilot of this, we were able to identify the differences in the amount of variation of power draw for the motor that spun this grinding wheel. And towards the end of its life, you could see how much variation you had when it was, definitely a bad wheel at that point. You could see that there was a huge amount of variation. And when you have a new tool, it, typically operated within a very, tight band. And so we were able to, as we went into production, refine this analysis using noise sensors, vibration, et cetera. But just even at a rough single metric power draw analysis, we were able to really hone in on what are those points where you need to start changing the wheel and avoiding bad parts. There are great dedicated SPC systems out there. In this case, the customer wanted some specific tweaks to the normal rules, and what we're able to do is just pulling this information that we were pulling into the BI tool anyway. We were able to grab that information using IoT, push that into the system, and then do a custom statistical analysis to really identify where you had out of control points. One of the interesting analyses that we've done is looking at autocorrelation over time for different tests. And in this particular case, we were looking at, does our result on, does a failure on this test on item number 1 actually predict that, the next item is going to fail? Or if we have 2 failures in a row or 2 within a certain amount of time, does that predict that we're going to have another bad part show up, next? And by looking at this autocorrelation, you can see, is it worth it to stop the line based on the type of failure that we're seeing, the type of product that we're running, et cetera, and being able to then say, if we get a random failure, but it's not autocorrelated to, a run of failures that's going to come, it's probably okay to continue running the line and just, continue testing. But if it's something where that particular test is correlated to very predictive of the fact that once it gets out of control, it's going to stay out of control, then you should immediately shut down the line, fix the problem, and then continue on. And so this customer in this case wanted to perform this analysis in order to be able to make that prediction. Some power generation examples. In this case, we were collecting information using IoT and then pushing that to the system for analysis. And if we look at the run chart, the red line up here was the setting for this boiler. And then the blue dots are the actual measurements. And what we see down below is the gap between the line and the data points. So kind of the setting versus the actual for the variance. And if we look at this, there aren't a lot of easy trends to pick up on. But when we reformatted that diagram and did kind of a graphical analysis on this, what we found was that all of the what they call dents took place at particular set points. And by through that realization, we're able to identify what were the causes for that within the process. And as you can see, when you weren't on those particular set points, there weren't those dents happening. When you were at those set points, you had a very high degree of variation. And so that was a key understanding for the engineers in that process to be able to make improvements to that process. So once we had kind of addressed that issue, then we did further correlation analyses to be able to look at a variety of different variables with the output and identify what were the real correlated factors, and then we could start to do some testing on that for causation as well. And then you can put all kinds of different visualizations and statistical measures in place. Looking at box plots or histograms and all kinds of different things. So then we have use cases around sourcing and supply chain and so forth that aren't as highly correlated to the IoT combination. And so for now, I'm going to just kind of show these on the screen, but not go through a lot of details because we do have some questions that I want to get to. So being able to go through here, do spend analysis, category analysis, some of the category management, being able to do supplier RFX result analysis and so forth. This one actually was more related to being able to collect that detailed information. With the planner buyer workbench, we combined some of the quality information that we were getting on the inbound inspection with some of the pricing that we were able to look at. And we really did, a detailed analysis on when we should, which vendors we should be selecting for some of these commodity items. So some of the closing thoughts, there are just an endless number of different applications that you can utilize both the IoT solutions and the BI solutions for. They really make a absolutely tremendous combination of capabilities within operations. And, you can bring the best of both worlds in terms of both the data capture, the real-time visual controls out on the shop floor, as well as more of that longer-term historical analysis to really kind of supercharge your improvement processes for operations. And once again, the key is not to just have all the pretty charts and graphs, but to actually embed those into your improvement process so that you can utilize them effectively and drive the improvements. So with that, I'm going to take a look at some of the Q&A questions that are out here. I think this one is primarily just a comment. I love the slide, The New World of Work. Thank you very much. And it is very important to be able to combine all three of those different elements. Let's see. Do I have a case study? Actually, I did go through a number of different case studies, but yes, I will talk to the person that submitted that, and absolutely contribute some of those, and have those discussions. In terms of CNC machines and different data sources, it can be more challenging to hook up to CNC machines than straight PLCs. But there are a variety of different IoT solutions out there that allow you to hook up to those. And in certain cases, you do need to work with your machine vendor, and it is they will charge something to give access to that detailed information. But it is possible with pretty much every piece of modern equipment. And again, thank you for the compliment that you enjoy the presentation. And for everybody, the presentation will be available. Both you can get a PDF copy of it, and the recording of the presentation will be available on my website at www.visualdecisions.com. And that should be available within a couple of days. If you want to, you can reach out to me at tim@visualdecisions.com or give me a call at 630-957-8096. For those of you that aren't in the US, that's a +1 country code. With that, I want to thank you all for attending today. And if you don't mind, I may be reaching out within the next week or two to get your opinions on the presentation and see how you're utilizing these tools within your organizations. Thank you very much, and look forward to speaking with you in the future.